Good morning. Now we will see, we have already seen panel point loads due to dead load and due to live load. Now in this video we will see due to wind load, and also we will see forces in the members due to these loads. Now I already mentioned, please go through these 3 videos and see the steps in detail in this one, so that it becomes easy for you to solve the problems in examination. So now we have step 4. We have wind load on panel point. Wind load on panel point. So we have given K1 is given 1, K2 is 0.98, and K3 we have 1. We have given as CT is Pune, and therefore we have VB is equal to 39 meters per second. Now design wind speed, you have to go to IS 875 part 3. So design wind speed is Vz is equal to K1, K2, K3 into VB equal to 1 into 0.98 into 1 into 39, and this comes 38.22 meters per second. Now designed wind pressure. So we have design wind pressure. Design wind pressure PD is equal to 0.6 Vz square, and we will get it as 0.6 into Vz is 38.22 square, and we have this value 876.46. 876.46 Newton per meter. Now we have first method. This is same for both. So in first method, wind load on panel point. Wind load on panel point is equal to CPE minus CPI into A into PD. Now wind load is always away from the wind. So we will consider minus 0.8 into, because we have given CPE minus CPI, that is plus minus 0.8. So we have taken 0.8 into area. It always acts on inclined portion. So 2.61 into 3.75. Sorry, into 3.5. And we will have into value of PD is 876.46, and we will get this value equal to 6.41 into 10 raised to 3 newtons is equal to 6.41 kilonewton, which is away from roof. Minus sign shows it is away from roof. This is one method. And second method we have wind load on 4 panel points. And here we have to consider total load equal to, so we have minus 0.8 into area only we have to change 10.44 into 3.5 into 876.46, and it comes 25,620.68 newtons, and therefore wind load on each panel point equal to 25620.68 divided by 4, and this value comes 6.41 kilonewtons. 6.41 into 10 raised to 3 Newton, that is 6.41 kilonewton. So you can use any one. So you can go by first method or you can go by second method. So now you can see we have, this is our dead load. And this angle is 16.7. Now we have this value 0 because we have T over there, and as these two are collinear, this becomes 0. We are interested with U7L8 and L7L8. Now we will consider joint L8, and for that one, we should know the reaction. And we have value of the reaction, that is 11.68, total load divided by 2. So it comes 11.68 kilonewtons. So we have 11.68 kilonewtons. And now we will go for this. So I will consider this joint, and let us, we will solve this. So I will consider joint. So we have this joint as L8, and reaction we have 11.68 kilonewton. Now let us assume tensile force in both. So we have this as FL8U7. And this is FL8L7. L7L8 and L8L7. We have same. So now we have vertical load over here. And we have this value 1.46. So we have only y component of this is unknown. So I will write summation Fy0 is equal to F L8U7 sine 16.7 minus 11.68 minus 1.46 equal to 0. Because we have this angle 16.7 and we have vertical component will be sine, and from this we will get, therefore, sorry, this is also plus and only this is minus. 11.68 upward, 1.46 we have downward, and from this we will get this value, that is equal to minus 35.57. So FL8U7 minus 35.57 kilonewton. So this is 35.57 kilonewton compression. Then now we know this force, which is 35.57 kilonewton, and that is compression. So we have to round up this and we have to show correct direction. Now unknown is only in x direction. So I will go summation fx equal to 0. And then we will get 35.57 cos of 16.7 minus FL8L7, which is equal to 0. And we will get FL8L7, and that is equal to 34.07 kilonewton. And this is tensile as value is positive. Now we have this as compression, this as tension, and force in member U7L7, FU7L7, and that is equal to 0. So we have these are the forces due to dead load in the three members. Now we will go to the live load. So we have this 3.59, we have this as live load. So this we have calculated due to dead load, and this 3.59 we have due to live load. And now we will get it as force in member. Now we have due to live load, that is equal to force in member due to dead load and multiply by live load divided by dead load on panel points. So now we have force in member, that is FL8U7, and that is equal to 35.57 multiply by 3.59 upon 2.92, and we have this value equal to 43.73 kilonewton, and that is compression. And then we have F L8L7 34.07 multiplied by 3.59 upon 2.92, 41.89 kilonewton tensile. So we have values in this fashion due to dead load and due to live load, and we have FU7L7, and that is equal to 0. Now I will not go wind load diagram and all this. We know we have wind load diagram. Let us, we will go in 1 minute. So we have 4 parts, 1, 2, 3, 4, and 1, 2, 3, 4. So we have these parts, and we are interested to find forces in these members due to wind load. So now we are likewise, and wind load is perpendicular to this. We have that is 3.21 kilonewton, that is end panel point load, and intermediate we have 6.41. 6.41, that is in kilonewtons. Then we have perpendicular to this 6.41 kilonewton. Again, this is 3.21. This is 3.21. 6.41. And this is also 6.41. 6.41. And then perpendicular to this is 3.21. And from this horizontal component of left side will be cancelled by right side, and we have to consider vertical component of this actually. So now we have 16.7, and therefore this again becomes 16.7. And therefore we will, if we will solve this, we will get reaction, that is vertical reaction, we will get downward because we have component upward. And I got this value 24.56 kilonewton. 24.56 kilonewton. And then we will find the forces in members. We have this as U7, L7, and L8. So we will consider this separately. So we have this as 3.21 kilonewtons. Vertical, we have 24.56 kilonewtons. This is 16.7. And we have this as F, L8U7, and F, L8L7. Now, same way, we will first go summation Fy0. We have FL8U7 sine 16.7 minus 24.56 plus 3.21 cos 16.7, that is equal to 0. And we will get FL8U7, and that is equal to 74.78 kilonewton, and as value is plus, so we have tensile. Then we have second now, summation Fx equal to 0. So we have minus F L8 L7 minus F L8 U7 cos 16.7 plus 3.21. Now we are finding component of this. This is theta, so vertical is cos. So horizontal we have sine 16.7, and that is equal to 0. And from this we will get F L8 L7, this is equal to, we have value that is 71, we will get 74.78 into 74.78 into cos 16.7. So cos 16.7 so I don't have actually calculator over here. So I got this value minus 71.05, and we have to deduct this minus 3.21, sorry, plus 3.21 sine 16.7. So due to this, we have 71.05, and then we have due to 71.05 minus 3.21 into sine 16.7, and then we have this value 70.13 kilonewton minus 70.12 kilonewtons, and this value we have 70.12 kilonewton compression. So likewise we have to find the forces in the members, and then we have to go combination of this. Now we will stop here only. Remaining part we will see in the next slide.